Again, you're welcome back to Quiver Analytics, and in this video, we'll continue with our Stata series, and that is examining the relationship between quantitative variables, that's continuous variables, otherwise known as scale variables, and I've said continuous earlier. All right. Now, in this video, in this course, we'll be using the baby's data, and the continuous variables we have here are maternal age, gestational weeks, and baby's weight. All right. So the first thing we do is to check for the normality, which we've done in earlier video, and we've seen that we do not have significant issues with them. All right. Now, another thing we do is we can check their summaries, which we've done. Again, I'm going to do it again. Summary and descriptive, summary statistics of maternal age, gestational weeks, and B weights. All right. Standard displays additional statistics that if we want. And use variables, display format, separated line, and okay. Now, these are the outcomes we have. If we want something much more succinct, we remove the details, and we have this. This is better presented in your work. All right, you can copy and paste this in Excel, and then do that. Now, the first thing we want to do is to check the relationship between. Okay, we can also do scatter plots. We've done some scatter plots before, and graphs, two-way graph creates. Okay, scatter, basic, B weights and gestational weeks, submit. All right, so we're going to have, you can see there is, we can observe a sort of strong correlation between the two, between weight of baby and mother's the gestational weeks. All right, so let's see more. Baby's weight and maternal age. Now submit. All right, so the correlation is kind of sparse. All right, so that means we should expect a correlation that is not so much. Then maternal age and gestational weeks. Okay, y variable, gestational weeks, maternal age. All right, then we submit. Again, not much correlation between them. Now let's carry out the correlation analysis itself. You go to statistics, summaries and tables, and then summary and descriptive statistics. Go to correlation and covariance, then select the category, the quantitative variables. That's the continuous variables, maternal age, gestational weeks, and baby's weights. All right, that's what we need. Then okay, so you can see the correlation between gestational weeks and maternal age 0.015. Correlation between mat age and B weight and maternal age is 0.033. Then B weight and gestational weeks has the highest. That means the higher, the older the pregnancy, the heavier the baby tends to be. And this is quite a significant correlation. It is high, it is strong, and it is positive. All the correlations are positive, while baby's weight is most correlated with gestational weeks, followed by maternal age. The older the mother, the heavier the baby, while gestational weeks is not really correlated. It's poorly correlated with maternal age. Baby's weight is also poorly correlated with maternal age. Now, having this, what can we say will significantly influence baby's weight? Is it going to be the maternal age or gestational weeks? So with gestational weeks, we have baby's weight to be 0.73. So we expect that gestational weeks should have a high influence on baby's weight. That's the higher the pregnancy gets older, the higher, the more the baby's weight. Now let's do that by carrying out a simple regression first. That's a one independent variable regression. So we go to statistics and linear model and related linear regression. Then the dependent variable is B weight, that's the birth weight of the children. While okay, the first thing we want to check is maternal age. Does it affect the children? And submit. Now you can see the code for simple regression. We have regress B weight. The independent variable, the dependent variable comes first, while the independent variables come after. That's for the simple regression. Now looking at our model here, what is important here is the probability of the F. This model is not so good because the probability for the model fits is high. It is higher than 0.05. All right. The R squared is also low. The adjusted R squared is even lower, and it is negative. It means that maternal age does not predict baby's weight. We've seen that in the correlation that maternal age is poorly related to baby's age. All right. Now, again, let's check without without going to the options. We just remove the maternal age and we try gestational weeks, then enter. Now, this time around, the model is good because the probability for the F value for the model fit is less than 0.05, which means that gestational weeks is strong enough to predict or to influence baby's weight. Now let's look at the coefficients. That's 206. For every single unit increase in gestational weeks, baby's weight increases by 206 grams. All right, because the quantity is in grams. Baby's weight increased by 206 grams, and this claim is significant. So we can say that there's a significant association between gestational weeks and baby's weight. Now let's perform a multiple linear regression. Linear models, linear regression. We still have baby's weight, the maternal age. Then we add gestational weeks to it, and okay. So again, this is significant, meaning that both of them can predict baby's weight. However, looking at the p-value for maternal age, we have 0.39. In this model, maternal age is not yet significant, so only gestational weeks remain significant. However, both of them can be they can be considered in the equation. Perhaps if the sample size is widened enough, they might be able to accommodate, we might be able to see a significance or the role that maternal age plays in baby's weight. However, for the samples we have, number of samples and the samples we have, they do not affect just baby's weight. All right. So thank you, and see you in the next video. Don't forget to subscribe and like this video.